Hey, this next video is on solving systems of equations using graphing. Also check out the other two videos I have using different methods.
Okay, what I want to say when I start graphing a system of linear equations is that this conceptually is a good way to look at it, but practically, when you're trying to solve the problem, this is probably the most inconvenient way of solving just any system of linear equations. So this problem actually does lend itself to graphing. I have two equations and I'm just going to graph both of them, and they both represent a line. That's why they're called linear equations, and I want to see where they cross, and where they cross, at one point where they cross will be the solution. So the first one has a y-intercept here at 1 at the point 0, 1, and it has a slope of 2, so I'll go up 1, 2 over 1, up 2 over 1, and it is this line along these points. So I want to try to draw the line, and on the system it's hard for me to draw it perfectly straight. There's a line right about there. And the next one, it has a y-intercept of 0, 5, so it's up 1, 2, 3, 4, 5, and it has a slope of negative 2, so I go down 1, 2 over 1, down 2 over 1, and it's this line. You notice I got to the point where they cross pretty quickly, and this is because I picked a problem that would be easy to solve using graphing. So here is the point, and that written out is the point 1, 3, and that is the solution to this system of linear equations. Okay, the next example, this is another one that lends itself to graphing. So I'll do the top one in blue this time, and it has a y-intercept of 4. 1, 2, 3, 4. And briefly, the reason I know that it has y-intercept is 4 is if I put in 0 for x, so negative 0 plus 4, then I get out 4 for y. So that's the point 0, 4, which is right here, the y-intercept. And it has a slope of negative 1, so go down 1 over 1. So there's a line along these dots that I'm putting. And this line, you can extend it. It's important to remember you can extend it as far as you need to as you get it across the other line. So the other line which will be way down here, I might have to extend that line a little bit longer. So the second one, it crosses the y-intercept here and has a slope of 1, so it's up 1 over 1. So they actually cross at a pretty convenient point here as well. Like I say, it's hard to get a straight line, but you want to try to draw that line as straight as possible, especially when you're doing a test or homework. And remember, you can keep extending it as long as you need. You just want to make sure you don't get off with the slope. So you can extend it as long as possible. You always want to put those arrows to say, you know, that line extends longer. You don't want to draw a line, a little stub of a line, because that says you may be confused about the fact that it's a line and not a small segment. So anyway, the solution here is 1, 3. The next problem. I can graph this one at the point down here 1, 2, 3, and have a slope of 2. And the other point, x equals 3, this is something that a teacher may give you thinking it's easy, it might actually throw you off. X equals 3 is this line here. Now, some people, when they see x equals 3, they manage to put a dot right there, and they don't know what else to do. But when x equals 3, this is x equals 3, y equals 0, because you don't go up and down. This is x equals 3, y equals 1. X equals 3, y equals 2, and anywhere in between, like 1/2. Well, when y is 1/2, x is still 3. That equation says x is 3, so it is a vertical line up and down. And I'm getting a bit messy, but here is the point where they intersect, and that point is, think about it, 3, 3, and that's the solution there. Now this is another one I want to show you that, well, it doesn't actually lend itself to graphing very well, in my opinion. So this is one that, if I started out trying to graph this, what I would do is find the x and the y intercept. So the x-intercept is going to be when y equals 0. So imagine if I put a 0 here, it would be x plus 2 times 0 equals 8. So I have an 8 there. So that's just one point for this particular equation. Another point would be, let's say x equals 0. Well, then 2y will equal 8. Think about it, 2y equals 8. Y equals 4. Now, I have this, but you got to keep this in context with that x was 0, then y is 4. Otherwise, don't think too much about that. So these 2 points I could graph, and I had to go out 8 pages. 1, 2, 3, 4, 5, 6, 7, 8. And the point 0, 4. 1, 2, 3, 4. And then draw a line as straight as possible. Now the other point, I'll let you try to figure out the x and y intercepts. But I get 1, 0 and 0, negative 2/3. So 1, 0 is here. 0, negative 2/3 is kind of cumbersome to graph. It'll be down here somewhere, so I know it's a line going up this way, so it's maybe crossing around here somewhere. So I want to get actually more points for this graph. I had the point 1, 0, and the point 0, negative 2/3. Now one way to solve this would be to solve for y first. So I'm going to subtract 2x from both sides, and I get negative 3y equals negative 2x plus 2. And now I need to divide by negative 3. I got to divide both sides, the entire side, by negative 3, and I get that y equals negative 2 over negative 3. Negative 2x over negative 3 is 2/3 x plus, well actually minus 2/3. Now if I try to put stuff in here, I could put a 2 here, but I don't think that'll work out all that great. And here's where 2 is, and I think it's coming up around this direction. So at any rate, I think 3 would be a better number to try. So I'm going to try to put in 3 here. So if I put in 3, I get y equals 2/3 times 3 minus 2/3. Well, the 3's cancel out. I get 2 minus 2/3, which isn't that fun. But what is 2 when I put it into thirds? Well, it's 6 over 3. 6 divided by 3 is 2. 6 over 3 is the same as 2. So 6 minus 2 is 4. And then on the bottom I keep that denominator 3, so I get 4/3. Well, that's not really any fun either. So I just try the next number up. So here I'm putting in 4. So here I get 8 over 3 minus 2 over 3, which equals 8 minus 2 is 4. 8 minus 2 is 6. And 6 over 3 is 2. So the good points to graph would be this point and this point would also be easy to graph. So the point 4, 2, let's see, go over 1, 2, 3, 4, up 1, 2. Conveniently is where that other line crosses, so I get that my solution is 4, 2. Now, like I say, here conceptually it's good to understand that these are two lines and we're looking for the point where they possibly intersect one time. That point where they intersect is a solution. But there are different ways to solve this problem using elimination or substitution, and I would opt for solving this problem using substitution. So when you're taking a math test, I would say the best time to use graphing is when it's something that you can see very easily, is easy for you to graph, and when the question explicitly tells you to do it. Because if the question says solve this system by graphing and you got a nice enough teacher, that particular problem is going to end up being easier to graph and get an answer, and it'll probably be two whole numbers like 4, 2. Not that this one was easy to graph, but it'll probably be easy to graph and your answer will actually be probably 2 whole numbers. Otherwise, I would opt for using elimination or substitution.
Thanks for watching. There are 2 other videos you should check out, and I may do another follow-up. There's one more video I need to do where you have parallel lines and where you have 2 lines that are actually the same line, and how those show up when you're going to solve a system of equations.